Good morning, ladies. How are y'all doing today?
Good.
Excellent, excellent. Sleepy. Okay. I see some of you already turned in your test. Dang, you talk about some awesomeness. Awesomeness. Very good. Okay, so do you all have any questions before we move on and finish 6? We're gonna do 6-1 and 6-2 today. Maybe 6-4, maybe. It depends. It depends if you all are able to understand the concept. It's easy. It's not difficult. Pen. My pens are running out of ink. I talk too much on my paper, right? So continuing on with 6-1. Okay, so we're going to talk about another distribution. Last time we talked about the uniform, and you had to use the formula length times width, right, to find the area of the shaded regions. Well, this one's a different graph. This one's called the normal distribution. Okay, this is on page 228. Okay, so the graph of it's not going to be rectangular. We're dealing with the graphs that are normal, the bell shape, like that. It looks like a snail, right? Okay, so that's the graph that we're going to be talking about, the bell shape. Okay. Now, the way it works, or the way the normal distribution works, it states that the mu, which is the mean is 0. And they say the standard deviation is 1. So let me write it down. This is mean, and the O is the standard deviation. All right. So how does that play out with the graphs? Well, the way the graph works is it's kind of like on the bottom scale, this line underneath the curve, right? Think of it like the number line, right? So the center is going to be the mu. That's the center. The standard deviation one is the labels, how they go in increments. Think of this line like the number line, right? So you have positive numbers on the right, negatives on the left. This standard deviation are the increments. How are they going in increments of? So it's going by 1 increment. So it goes 2, 3, and then it goes, because it's symmetrical. So these are positive, the other side is going to be negative. So we go -1, -2, So that's why the graph is labeled like that. So if your standard deviation were 2, then these would go in increments of 2. It would go 0, 246 or -2, -4, -6. So this sigma standard deviation are how the increments are going. So that's how you label your axis in the bottom of the graph. And what we're going to do is we're going to be shading parts of the curve, and we're going to figure out the percentage of it shaded. So our goal is to find the area of the shaded region given a z value. So this scale, that scale is the z scale. This line here is your z-score value. Remember we talked about z-scores a long time ago? We talked about the heights of people. Well, that's what the z is. That's that scale. All right, so I'm going to show you all how to do it. It's very simple. Okay, so I'm going to draw another curve because I really need to practice, right? That looks terrible. I'm going to see if I can draw another. Yeah, whatever. 0, 1, 2, 3, -1, 2, 3. So if we were to shade the whole entire graph, whole thing, okay, the area is 100%. Because it's completely covered up. I didn't cover it all up. It's entirely covered up. So that's 100%. Or if you want to put it in decimal, this would be 1. So this is in percent, and this is in decimal. I'm gonna graph another one. I just love to graph. No, still not good. Sorry. If I shaded half of it, like that, what do you expect the probability to be? Right? Because the area is half of it. Shaded. Well, it's half shaded, right? So that's 50%, right? Because half of the graph is shaded, or you can write it in decimal, 0.50. It's half is shaded. I didn't color this dark enough. Sorry. There we go. My shading's terrible. Well, these two are gonna come out nice, right? So yeah, they come out perfect. So you can visualize it, but sometimes you won't know like what that piece is. We don't know what the shading of the piece is going to be. If I gave you a z-score number, like right there, I drew a line and I shaded it, you're not going to know what that percentage is. So I have to show you how to use StatDisk. And StatDisk will determine the percentage for you. It does it automatically for you. So all you have to do is just recognize the different shadings that are going to be occurring in these graphs. So let me show you the there's going to be 3 inequalities that we're going to be covering in this section, and we're going to be doing this pretty much the whole week. So if you don't understand it at the beginning, you will, because it's going to be continuous. You're going to continue using this process. All right, so inequalities. There are 3 of them. We're going to use, and we're going to be using probabilities. So we're going to write P for probability, and then for parenthesis, we're going to put a parenthesis, and then you're going to put Z, because that's the Z scale, and then you're going to have this inequality. That I'm going to put a letter. I'm going to put A. A. All right. So what is this little symbol right there? Does anyone know what that symbol is called? The inequality symbol. What is that inequality symbol called? Is it less than? Is it greater than? Which one is it? Anyone want to take a guess? Is it greater than or less than?
Greater than?
Ah, you're close. Close. It's the less than, right? So in school, this is how I was taught about distinguishing between the less than and the greater than. We were told about the Pac-Man, the openness of the symbol is going to eat up the bigger number. That's how I was taught. That's weird. But Pac-Man, yeah, you can tell my age. Whatever. I think some of y'all were taught with the alligator, right? The alligator eats the bigger side, something like that. But a student of mine told me, look, sir, you don't have to run it like that. He said, look. She said, look. Doesn't it look like a capital L, but sideways? Hence, less than. Get it? Like, oh my God, that's true. It does look like an L. So there you go. There's your less than. That's how you know. So I remember that one when I asked the girls on to the prom, they were showing me that on their forehead. I don't understand why. I guess they were telling me I was less than. They were less than me. I don't know. We don't judge. Anyways. All right. So graphically, this is what it looks like. All right. So graphically, it goes. Oh, that's a terrible one. It looks like pan. All right. So I'm gonna put 0 there. I'm gonna center it in the middle. And I forgot to tell you too, the graph is symmetrical. We'll talk about that in a little bit. Symmetrical. Okay. So I'm gonna put A. A could be, if A is positive, so if A is positive, you're going to go on the positive side of 0 and you're gonna plot it. If A is negative, you go on the left side of 0 and you would plot it. So it doesn't matter right now. We're just gonna do it we'll just make it a positive. Let's say that A, there's my A. I put it right in between the 1 and the 2, right? So there's my A. So you're gonna go and draw a line, right? And then you got to figure out, well, what do I shade? Well, the point of the inequality is telling you the direction of where you're graphing. So you're going to shade to the left. all of it. From that line, wherever A is at on the Z, you plot it and you draw a line upward, and then you shade. You're gonna shade that region. There. Again, if A is negative, you would draw your line there and then shade that one. Right. So that's how you shade a less than. You plot your A on in the scale. You plot your A, draw your line, and then you shade in that direction. You're going to shade to the left. All right. So we got less than. Okay, that's the less than. To move it up. I can draw. Yeah, I can't draw it. I can't draw it on the same paper. All right. Let me draw another picture. I'm going to draw another picture. Why is it crooked? Let me draw another picture. Oh, no, not yet. Right. The second one, I forgot to put the second one. Second one goes probability of Z, and then you have that. And we'll put B. B. So the symbol is the greater than. Right. So that was pretty cool. How that was very ingenious. How my student told me, "Hey, it looks like a capital L, right?" Okay. Now this one's the other one. This one's the greater than. Right. So how do I remember? I told, hey, so this would be greater than. See it? See it looks like a G, kind of like it. No, maybe greater than. Looks like a G, kind of. You turn your head sideways, maybe. Oh. Greater than. That one is the greater than. Okay, so this one graphically, I have to draw it. I'll put B. I'll make it positive also. I'll put B here. There's my B. Okay, now this time it's greater than, so you're going to shade to the right. Less than, you shade to the left. Greater than, you shade to the right. Now I didn't say shave. I said shade. Sorry, sound like I said shave. I can't color, ladies. I'm a male. What do you expect? All right, there's my shading. Right, greater than, you shade to the right. Less than, you shade to the left. To the left, to the left. And you shade to the right. Greater than. Okay, and don't worry, I'm going to show you in a minute how do we find that the shadings within the graphs. I'll show you how to do it. All right, so there's one more. There's one more we got to go through. So we got less than, we got greater than. There is a third. Right, the way the probability is written is written this way. It goes probability A less than C less than B. Okay. This one's written weird, right? You're like, well, it's A less than Z less than B, huh? This one is the betweens. Notice where is Z with respect to the A and the B? It's in between. So this one is a in between. In between. That's an in between. So you remember Beyonce's song, right? Her favorite song. What was her favorite song of all the songs that she's written? What's the name of the song that she goes to the left, to the left? I don't know. Anyways, that's to the left, to the left. Get it? Because they're both less thans. To the left, to the so they're like L's. Left, left. Anyways. This one you shade in the middle. How do I do it? You have two arrows pointing each other? I can't draw it. Shade, not shend. Shade in the middle. Okay, so let me draw a picture of it so you can see how it goes. One, two, three, -1, -2, -3. And let's say that A is, we'll say A is right here. There's A. And then B is somewhere right there. There's B. And so you would shade in the middle, in between the A and the B. So you just shade all the area in between. Yeah. Stop making fun of my drawings. All right. Anyways, there you go. There's my in between. So if you all see this long freaking thing like that, that's gonna be an in between. That's an in between. Oh, my paper. My papers fell. My papelitos fell. An in between. Right, so there are three cases. Right? You have less than. Where did I do with it? I have the less than. Right? You got the less than. You got a greater than, and you got an in between. That's a terrible greater. It's a small lowercase g, but yeah. There they are. There's the three. Those are the only three inequalities that we deal in this section. So how are we going to find these shaded regions? How do we find them? How are we going to find these shaded regions? Okay. So the handout that I had you make a copy of last week, you're probably gonna need to get that sheet out. Let me put it in the chat. I'll send it to you again. There you go. Sent. So look in your chat and I send it to you again. Just open it up or you could print it. It doesn't matter. But just have it ready. I'm gonna explain to you how we're gonna find those shaded regions. Okay, so let me bring it up. The little chart, the little paper. What did I do with it? Ooh, my ear popped. Oops. Huh. Where did my space come up? Okay, so this handout that I shared with you, now, you can do it by hand, all right? The first page of this handout that I provided you with, the top part, this part right there, where it says finding the area from a z-score, that's doing it the long way. So if you want to use the book, they have a chart in the back of the book, and you want to do it the long way, you can do it the long way. That's fine. I can show you how to do it the long way if you want, or you choose for me to just show you the shortcut, the stat disk, which I think you should just do it that way because I don't want to confuse you all. But this first 3 lines tells you how to look it up in the book, which it just takes too long. This is the formula that you guys are going to be using in chapters 6.1 and 6.2. Okay, there's the formula. There's a z-score formula. Remember we did that with the heights of those people, right? And we took your heights as well. And of course, you guys are going to have to draw. You have to draw the pictures. You will have to draw the pictures on your homework when you all do your homework on 6.1. You'll have to draw the pictures, right? And that's how you label it. There's going to be another formula that we're going to be using because this one's backwards. All right. So what we're going to do is, you know how we shaded the regions. We want to find the area. Well, this one's the opposite. You're given an area, you want to find the value where it came from. It's going backwards. So we're going to show you how to do it forwards and backwards. So that's what the front page is, just as a reference, the formulas, or in case you all need to do it the long way, that's fine. That's what the first page is. The second page will show you all how to use StatDisk. And I think it looks the same as it does on this handout. If you go to StatDisk and you upload the online version, it should look like that. It should look exactly like that, I think. I don't remember. It's been a long while. I'm getting emotional. Hold on. Got something in my eye. Alignments. Okay. All right. So here's what you do. So you're gonna go on StatDisk. You're gonna click on analysis, just like we did with the binomial, right? You go to analysis. You go to probability distribution, but instead of going to binomial, you're gonna click on the normal distribution. And you should get the screen. You should get the screen on there on your StatDisk. All right. So what you do is they're going to give you a probability, and that A and that B are going to be numbers, right? That A, let's say that Z is less than 2.4 or whatever, 1.34, right? So you put that number in the first box. So if you want to find the area, right, you're going to have to put the number that's provided to you in that probability, and you're going to put that number right there. Now you got to make sure that you have the right sign. If it's positive, you got to make that circle number positive. If it's negative, well, then you have to put a negative. Yeah, it's next to the 0 key in your keyboard on your computer. It's next to the 0. You put the negative and then the number, and then all you do is you hit evaluate, and then boom, you're going to be getting these values, right? So this top value is just showing you, is that the same number that you entered? Yes, that's the same. Yeah, that's good. So that's what that is. And then hold on, I need to do some highlights. Where's my comments? Hold on 1 second. All right. So then this number, make sure that number is the same as that number, because sometimes you're going to be using StatDisk, and you type the number in, but you forgot to hit evaluate, and that happens a lot. So you want to make sure that when you hit evaluate, that number and that number are identical. Otherwise, you didn't hit evaluate. Hit evaluate a couple of times just to be sure. I hit it like 10 times in OCD. Anyways, all right. So then once you have those numbers, these two numbers right there are what we're looking for. We don't need to worry about this two-tailed thing. We can scratch that out. We don't need that. We don't need that information. We don't need central either. We don't need that. Or we don't need that either. All you're looking for is the left and the right. So this is where you remembering the symbols, right? You got to remember the symbols. So remember, left is the less than. I hope I can draw the less than. And the right is going to be the greater than. Okay, less is left, right is greater. Okay, less is left, right is greater. So go ahead and put that in your paper. Less is left, right is greater. And whatever the inequality symbol is given to you, that's the value that you're going to be writing down. So I have it here. Look, on my notes, I have the arrows pointing to what those probabilities. So you have, when they give you a probability z less than a less than, it's going to be this long number right there. If it says probability of z greater than a, these numbers, so symbols right there, those symbols are what we're looking for, then it'll be the bottom one, right? And notice I even have it highlighted for you. Look, ladies, round your answers to 4 places behind the decimal, right? So the previous test that you just took right now, you rounded to 3. These you have to round to 4 places. So you have to have 4 digits behind the decimals when you calculate the areas, right? And then I'm going to show you all how to do the in-between. Now the in-between is a little bit more challenging. So less than and greater than, they're easy. You just spot them. Those numbers right there are your less than, greater than. When you do the in-between, right? This is the one where you're gonna have to use Beyonce's song. So I can draw a symbol, a note. Can I draw a note? Does that look like a music note? Let's see if I can draw it. To the left. Oh, to the left. Dang, I was practicing with my the spray paint. There we go. Boom. There we go. To the left, to the left. There's your my son's gonna kill me if he saw my symbols. That's how you draw them, dude. There you go. Boom. I put Jay-Z. Get it, Jay-Z. Anyways. All right, there you go. You gotta remember the lyric. To the left, to the left. Right. So when you all do the in-between, here's what you do. You're going to enter on StatDisk. You're going to do it separately. You have to enter the B, or actually you have to do the bigger one because it's like the number line. The number on the left is going to always be smaller than the number on the right. Right. This number is always bigger than this one. It's always like that. It's traditionally it's supposed to be like that. It's supposed to be in descending order. All the numbers on the left is smaller, and all the numbers on the right are bigger. So what you do is you enter the bigger one first. So you're going to look up the A, And you're gonna look at the left area. Left. Right? And then you do this one. Okay, so that one, you do that one. And then you do this one too. You enter the B, shoot. And you find the left area. And then you're gonna subtract them. Shoot, I messed up. You can't see it. There it is. And you're gonna subtract the left areas. That's why there's a minus. Left minus left. And that's how you're gonna find the area of the in-between. You gotta look up both of those numbers separately, write them down, and then subtract the results. All right, so we'll go through examples of each so you all can get the feel for what the heck. These are supposed to be exclamation points. There we go. There we go. To the left, to the left. Does anyone want to sing it just for kicks? Ladies, no. No, don't do grito. That's different. That's a different scenario. That's a different culture. Yeah. Okay. All right. So we're gonna do the ones in the book so you can work. Well, actually, I'll make them up so you can see how they work, and then we'll do the ones in the book. All right. Let me get you guys out of the way. Get out the way. All right. Let me see. Let's practice. I'm gonna do one of each so y'all can see it. Remember, you're gonna have to draw them. So if you're not an artist, well, you will be soon. Okay, so here's our first example. So suppose they ask you to find P probability of Z less than 1.65. 1.65. Yeah. 1.65. Okay. So they're gonna give it to you. Sometimes they might not write it like that, but you're gonna have to convert it to write it like that. Well, you'll see in the homework. Right. So what you do is you're gonna draw your picture. You gotta draw a picture. Sorry, you have to draw your picture. If you can get the feel for it. 0 goes there. 1, 2, 3. -1, -2, -3. And you're going to plot 1.65. Where do I put 1.65? It doesn't have to be like accurate. Just make sure that you have it placed. Right? So it should fall maybe about right there, right? 1.65. Más o menos. Right, so you draw your line, right, on the 1.65. Now, which side do you shade? Do I shade to the left or to the right? Because it's less than, I need to shade to the left. So you shade. That's the sound effects. You ladies can draw better than I can. You're probably gonna need some like map colors or crayons or blood, whatever. Makeup, maybe you have old makeup you want to use. Yeah, you can. There you go. Boom. Holy cow, that looks weird. Okay. So I know it's left. Oh, that's supposed to be an arrow. Okay. So now you're gonna go to stat disk and we're gonna enter this number. We're gonna enter that number in that first window. All right, so here we go. I'm gonna go to my stat disk. Where's that? Oops, I didn't open up stat disk. Okay, hold on 1 second. I forgot. Oops. Okay, there you go. Clear. Share. Okay. So we're gonna go to analysis. We're gonna go right there, analysis. And then you find the first one, probability distribution, just like we did the binomial. And then the normal is going to be the very top one. So analysis, probability distribution, and then normal distribution. And then wakataka. Right. And so we're trying to find the area. So what you're going to do, there's going to be two windows. We're going to put that number into the first window. So I'm going to put 1.65. Right. 1.65. You hit evaluate. All right. That matches. Yep. All right. And so I shaded to the left. So there's my answer right there. Boom. But I gotta write it in as 4 digits. That one has 5. So it has to be in 4. So it looks like it's gonna be 0.9505. 0.9505. And there's my answer. The end. Swish. 0.9505. You can write it in that manner if you want, or you can write it as a percentage. You can write it as 95.05%. And that's what the shading is. That shading covers 95.05% of the graph. Of course, I didn't draw it nice. It should have been more colored in, but that's it. That's all you do. We just type it in, boom, they get the answer, round it to 4. There's your result. Okay. Questions? Pretty straightforward, right? It's nothing fancy. All right, let's do another one. Let's do another one. Let's find the probability of z is less than negative 0.77. There we go. 0.77. Okay. So you draw your graph. Oh, you attempt to draw the graph. That was just atrocious. That one stunk. PU. -1, -2, -3. Right? Now I want to plot negative 0.77. Well, that number is going to go, I know it's between 0 and -1. So I'm going to just say it's about right there. Más o menos. Yeah. There is 0.77. It's less than, which means I have to shade to the left. No, I just want that left. And so you just delta side effects. So you colored it in. I'm going to enter this number in the first little window on StatDisk, right? So I'm going to go over here and put that into StatDisk. Let me see. Shunt. No, I don't want to shunt. I'm and I'm gonna put negative. Negative, that's the button next to the 0 key, right above the P, I think. Well, in between the P and the bracket. Negative 0.77. Right, you see if I don't hit evaluate, the previous number's still going to be there. So that's what I mean. You have to be careful. Make sure that you hit evaluate. See, I'm going to hit it 10 times just to make sure. Okay, there we go. All right, that meant you can just do it one time. I'm just being silly. That number and that number match. That means I calculated that I had it done correctly. It's computed to the left. There it is. Boom. I got to round it to 4 places. So that would be what? 220.0.2207. Yeah, that 6 is going to be increased because the number next to it is 5. So I have to bump that 6 to a 7. So it'll be 0.2207. I'm going to share my screen. Or you can write it as a percentage, 22.07%. Either or, ladies, you choose whatever you like. Now, if you're gonna go, well, none of y'all, half of y'all going into medical. So I would suggest that you do the percentage. That's just my thinking. But anyways, that shading area was 22.04%. That's how much shade was done by plotting that point on the graph. So that's the those are the less than's. Okay. So let's do 2 examples with the greater than. No yawning. All right, here we go. Find, oh, great, I cannot think of a number. Let's think. Z is greater than 2 point, let's see, how many beers did I drink this weekend? 86. All right, there you go. 86. 2.86. Okay, so notice that this symbol is greater than, which means when I go and shade, I have to shade right. And I always put it on top of the inequality, the direction I'm going to be shading, so that way I won't forget. Okay, I'm gonna draw my graph. You draw your graphs. Eventually, your graphs are gonna come out smooth and crooked. 1, 2, 3, -1, -2, -3. All right, I'm gonna put 2.86. All right, so 2.86 is about más o menos right there. I'm gonna shade to the right. Ooh, look at that. It's gonna be a little bitty little deet. Right there. That's gonna be, I'm thinking that the percentage is gonna be tiny, right? Well, let's find out. So I'm gonna go to my stat disk and I'm going to enter 2.86 in that little window and we'll figure it out. 2.86. I'm hearing noises, sorry. I'm hearing voices. I'm kidding. No, I'm kidding. That was yesterday. 2.86. All right, so I'm gonna put right here on this window 2.86. 2.86. I'm gonna hit evaluate, right? And because I shaded to the right, I'm going to get the right area. There it is. Boom, I got around to 4 places. So my answer would be 0.002. I need a one more digit. Okay, 21. 0.0021. Or this would be 0.21%. That's the amount of percentage that's been shaded in. It's a very small number. Small. Kind of like the IQs of our politicians in Texas. Small. Teeny weeny. There you go. It's teeny and weeny. 0.21%. Again, you decide. I will take either or. That one or that one. That one or that one. It doesn't matter. You pick. I should hit the piñata. There's no candy coming out. When was the last time you hit a piñata? Jeez, when was the last time I hit a piñata? I don't even think I ever hit a piñata. I don't think my parents ever. Oh yeah, we did have a piñata, but they didn't want me to hit it. It was too pretty. Well, why'd you buy it for? It was in the closet for years. Great. It was a huge piñata. I don't know what the heck it was. I guess it was a birthday cake. I don't know. Something. Shaped like something. All right, so let's do another one. We'll do another one that's greater than. We'll do a negative. We'll have to do one that's negative so you can see how they play out, right? All right, so let's find the probability that our Z is greater than, let's think. Oh, let's do 3.54. There you go, negative 3.54. Right, so you're gonna draw the picture. 0, 1, 2, 3. Every time I draw a picture, it keeps getting worse. Or is it worser? I'm not too sure. Right. And we know that the symbol is greater than, so I know it's going to be shaded to the right. To the right, to the right. All right. So negative 3.54. Ooh, that's going to be over here. I'm going to say about right there. Negative 3.54. Yeah, right there. So notice that almost the whole graph got shaded. Almost. Right? Almost got shaded all the way in. So that means the area is going to be pretty, it's going to be pretty big. All right, so let's see. Let's go enter in my stat disk. I'm going to enter negative, don't forget the negatives, negative 3.54. Negative 3.54. And I want to get the right. Well, look at that. Now, ooh, that's going to be 99.98, 0.9998. It almost covered the whole thing. Almost. 0.9998 or 99.98% of the graph is covered up. Almost covered the whole thing. Pretty snabby, huh? Pretty snabby. For my graph. I need it for my next class. Questions, ladies? You ladies are good so far? We did two less thans. We did two greater thans. All right. So we need one more. We need to do examples of where the in-between ones, which are the fun ones. Those are going to be fun. All you have to do, ladies, is you got to remember Beyonce's song. You got to remember Beyonce's song. That's all you have to do. Remember Beyonce's song. To the left, to the left. I'm not going to sing it. I don't want to embarrass you. Right. Okay. So this is what a in between looks like. So you're going to have a probability. Find the probability of, let's think. 1.04 less than z less than 2.62. All right. This one is in between. I'm going to put it on here. In between. In between. I should put arrows. In between. There you go. That looks nice. In between. Okay. So you're gonna draw your graph. There's 0, 1, 2, 3, -1, -2, -3, and you're gonna just have to wing it. 1.04. 1.04 is positive, so I'm gonna say it's about right there. 1.04. That's about it. Más o menos. You're gonna have to wing it. And then 2.62, they're both positive, right? So they're both gonna be on one side. 2.62, I'm gonna say about right there. Plus or minus. And I shade in between. So your goal is to find that area that's shaded in between the 1.04 and the 2.62. Eesh. That is one ugly graph. Right? So what do we do? So you're gonna have to look up the left area of the 2.62. And then you're gonna have to look up the left area of the 1.04. We're gonna have to look up both areas. And then after we do that, then we're gonna subtract them. Okay? So remember left. So I'm gonna type in first, I'm gonna type in the 2.62 first. I'm gonna get the left area. I'll do that in a minute. Hold on. I'm gonna wait till you guys copy that first. Ready? All right. Okay, so let's go and type them in. 2.62, and then we'll type in the 1.04. This is the 2, looks like a freaking Q, and my 4. Okay, sorry. So sorry. Okay, here we go. So go to stat disk, and we're gonna enter first the 2.62. Make sure I hit evaluate. All right, remember Beyonce song, to the left, to the left. There's my left. 0.9956 is the left area for 2.62. 0.9956. Okay, so we got that one. Okay, now I have to enter the 1.04. Hit it a couple of times. All right, I want the left. There's my left. 8508. 0.8508. Yeah, I don't have to change that 8, the last 8 to anything because it's 3. Right. So now I have the 2 areas. Right. I got both areas of the left. Of the left. To the left, to the left. Beyonce. And now all you have to do is we're going to now, once you get those 2 areas for these 2 numbers, right, you just reverse them. Right. Find the areas. Now you subtract. So now I'm going to subtract 0.9956 minus 8508. 9 by boom. 0.1448. Or 14.48%. Okay. Now, if you accidentally haven't had them reversed, right? And you had 8508 and then minus the 9956. Well, let's see what happens. What happens if they were reversed? Right? If you enter it, you get the same answer, but it's negative, right? So what do I do? Well, all you have to do is just take off the negative. If that happens, because areas cannot be negatives. An area always has to be positive. You're measuring an area of something, it's always positive. So in case that happens, just take off the negative and you're good. Remove if present in the final answer. Some of you are gonna leave it on there. Ooh, Mr. Garrett's gonna get mad. He's gonna have a tantrum. Start rolling on the floor. So you can't lose on this one. If you enter it, if you find the areas of both of them to the left and they're reversed, and you get a negative, that happens. Take it off. Just take it off. Okay, questions? All right. Let's do another one. Just for kicks. Does anyone want to give me some numbers? I'm running out of numbers. I can't think of any numbers off the top of my head. I can't think. Let's do find probability of Desiree, what's your favorite number?
24.
Great, 24. Okay, good. That's a good one. 24. How many brothers and sisters do you have?
2.
2.24. You sound happy. Desiree, don't be mean to them. They're your siblings. Yeah, you can hit them a couple of times. That's all right. All right. Okay. Let's see. And Victoria, what's your favorite number?
22.
22. And how many brothers and sisters do you have?
5.
Wow. 5?
Yeah.
Ah, wow. Yeah, and how many favorites do you have? I'm kidding.
2.
Ah, qué malos. Well, you're the best one of them all, right? 1.20. Yeah, you're the best one. There you go. Yeah. All right, good. All right, we'll do negative 2.24 less than z is less than negative 1.22. All right, cool. Excellent. Jeez, my graphs keep getting worser. And was that a word? Is that a word? Worser? If not, I'm gonna make one up. Freaking worser. All right, anyways, 1. That's why I majored in math. -1, -2, -3. All right, there we go. Más o menos. All right, so what happens if I have 2 negatives? All right, well, we plot them. 2.24. I'm gonna say 2.24. It goes a little bit beyond -2, so I'm gonna say about right there. There's your -2.24. And then -1.22, it's on my negative side. So I'm gonna say, más o menos. And so I'm gonna shade in between. That's probably my best shading I've ever done in my life. Golly. Woo! I'm gonna be like Ric Flair. Woo! Okay. Right. So now we're gonna find the area in betweens, which means I gotta look up the left area. Left area of I gotta put the bigger number first. So I gotta put this one first. -1.22. And then I gotta look up the left because it's Beyonce song. To the left, of -2.24. That goes first. That goes second. Anyways, that's how that goes. That's how it works. Okay, so we're gonna go in stat disk and type those numbers in and just get the left there it is. Here we go. Come on. Okay, here we go. 1.22. I hit it a couple times. I'm gonna hit it a couple times. I'm gonna hit it a couple times. Okay, I think it's ready. All right, I need the left. 1112, I believe. Yeah, 1112. 0.111112. Okay, so that's for the negative 1.22. And then I got to put the negative 2.24. All right. I want the left. 0.0126. 0.0126, or the 5 is going to change to a 6 because the next to the 5 is a 5, so that first 5 is going to change to a 6. Okay, there we go. Got my numbers, and I am ready to subtract. Yeah. 0.1112 minus 0.0126. Let's see it. Oh, 986 is my final answer. Or 9.86%, if you want to do it that way. There you go. So there's your examples of two in betweens. You have to just enter those two numbers. You gotta enter that one first, that one second. I should have labeled it. 1 and then 2. Right? And then subtract the two areas. Pretty straightforward, right? Pretty easy. Okay, so shall we do some from the book? So you can see how they work. I'll let you pick some from the back of the book. Well, not the back of the book, but from the book. The exercises from the book. The Libro. All right, let me see. I'm gonna switch over. I'm gonna go to page, what page is it on? The exercises begin on page 241. There you go. Actually, number 9. My bad. Let's do number 9 now. Sorry. All right. So let me show you how the book starts it off. All right, 240. Number 9. Here we go. Number 9. All right. Here you go. So how do we do those? Okay, so number 9, they gave you the picture of it. Okay, so they're giving you the picture of the probability. You have to write out the probability statement that pertains to that picture. So there's our picture. So how would you all write the probability statement? I know I have to put the P and then parentheses, Z is what symbol? And then I have my 0.44. What symbol goes between the Z and the 0.24? This is what I want. I need to figure out what is that inequality symbol that goes in between there? Was it less than or was it greater than? Go back to the picture. Which one was it? Which way is the shading? The shading is the green, not the white, but the green. Which way is it shaded? That's correct. It's shaded to the left. So that is the less than symbol. So it should read Z is less than 0.44. So this one you don't have to draw a picture of because they already have a picture. So this is what I have written on my paper. That's what the inequality or the probability statement is supposed to be with respect to that graph that they drew for us. It's Z is less than 0.44. So it's shaded to the left. All right, so that means I'm going to put my number in 0.44 and let this do it for me. $44. Negative or positive? There you go. Left. 6700 or 67.0%. I'm going to check the answer in the back of the book. It is correct. It's been confirmed. Booyah. Too easy. Okay, next, let's do number. What are we gonna do next? I guess we'll do the odds, huh? Should we do 10? We better do 10. We better do 10. I know it's not in your homework, but oh well. All right, so how do I write my probability statement? For number 10, which way is the shading on this one? This one, the shading is going to be on the right. So I'm going to do greater than negative 1.04. See, it's shading. The shading is occurring to the right. Right. To the right, to the right. Oh, the answer isn't here. Just saw my security blanket. Boom, there it is. To the right. It's shading to the right. So I'm going to put that number into my stat disk and I want to get the right area. The white. Negative 1.04. Right. 8508. Or 85.08%. Booyah. Let me check the answer in the back of the book. Got it. Easy and cheesy. Oh no, how did I get dirt? Questions? Okay, let's do 11 then. 11. All right, so I need to write the probability of, or you ladies tell me what's going on with number 11. How would you write number 11? Notice that the shading is occurring in between. So that's the one where you have to do the in between. So this is the one where you're gonna have to put the smaller number on the left, bigger number on the right. This one's easy because you put negative 0.84 less than z less than 1.28. So this is how you draw the probability statement from number 11. It looks like this. It looks like these. Uh-oh, someone left. They got mad. Se enojaron, ni modo. There you go. Boom. That's how you write an in-between. That's the in-between. Okay. So how do we do it? You all remember? We got to look up the left area of 1.28. And then we got to subtract the left area of negative 0.80 quattro. Okay, so now let's go to stat disk. This is how you do it. All right, sorry. 1.28. Left. 8997. There you go. 8997 is the left area of 1.28. 0.8997 menos. Now I'm going to put the negative 0.84. Negative 0.84. Huh. It came out to the same answer. 8997. What did I do wrong? Is that right? 8997 also? Oh, yes, that's correct. I didn't hit evaluate. Hello. Hello. Duh. I forgot to hit evaluate. All right, left. 2005. That's when some of you were born in, right? 2005. Oh, no. You would be too young right now. Never mind. 2005. 2005, you guys were like, what, 4 or 5 years old? 3? Yeah, probably 5 years old. You're watching Dora the Explorer, Clifford the Dog, 2004. Dora! I remember that they had a spin-off, the Chinese version of Dora the Explorer. Remember it was Ni Hao Kailan? Ni Hao Kailan, I remember that one. The name of that, you remember the name of her grandpa? Her grandpa? It was Ho Ho. Weird. $69.92. $69.92%. I'm gonna put that in a freaking large box. Boom. Let's see, what do they have in the back? $69.92. Booyah! Ah, we're so good, aren't we? Okay. So there we go. We took care of. I wanted to do those so that way you all can see the picture and how do you convert them pictures into probability format, because you need both. You need to be able to write a probability statement like that, and then you also need to learn how to draw the pictures. Okay. Questions? Told you it's easy. Easy. It's like brain surgery. Simple. Snip, snip. There you go. Done. All right. So that took care of that. Now, we can't do 13, 14, 15, 16, 17 yet. We're not ready for that. You guys are little peasants. You're still rookies. You don't know. But we can do 17 through 36 if you want. We can pick some. All right, I want you to look through the list from 17 through 36. I want you to pick me, ladies. Pick 3 of the hardest ones from that group there. Which ones look difficult? You pick. Which ones should we do? Or should I do? Or should we do? You pick. Which ones look difficult? Oh, what the heck? Anyone you want to pick? Or you ladies good? No? You're all good with those? What? What? All of them on the right-hand side? Hello? But those are evens. You want to pick some? Give me 3 from the right side. Sure, I don't mind. Give me 3 of them from the right side. We can do even, I don't mind. You have any suggestions? They're all easy. We did one of each, but yeah, give me 3. Give me 3 from that right side. Which ones do you want? I'm good. Pick.
32.
Oh, you had to pick that one. All right, 32. What other one? Oh, someone said 32 on the left side. Okay, on the left. 32. All right, I'm writing it down. 32. Okay, what's another one? Okay, got another one. 32. I say, sure. You say left. All right, pick. Give me 2 from the left side. I got 32. We'll do 32 for sure. What are the ones on the left would you like? All right. Okay. We got 29, 17. Holy cow, I said 2. 35. Son of a biscuit. Hey, wait a minute. You gave me all of them. Yeah. And we get that. Yeah. That's 4. 4. I asked for 2. All right. Let's see. All right. So, well, we're gonna have to do 32. So we're gonna compromise. Let me see if there's any overlaps. All right. So 17 is an overlap between Enriqueta and I'm not mentioning your names and Natalie. And let me see. Ooh. Let's see, 29. All right, we're gonna do 32, 29, and 17. Good job. All right, we will do those 3. All right, so let's show you. You want me to go in order or out of order? You're out of order. You can't handle the truth. All right, let's do 32 first. 32 by request. That's odd. No, I'm kidding. It's even. All right, 32. 32. All right, so 32 reads, what does it read? Between, oh, wait, 32. Yeah, between negative 4.27 and 2.34. Oh, okay, so that one's gonna be in between. So I gotta write my probability statement. So I'm gonna put P parenthesis negative 4.27 less than Z less than 2.34. Okay, so that would give it away. It said between. So this is how I wrote it down on probability notation. So this is how it's written in this format. That's how you write it. Small number, bigger number. It's always small, bigger number. Left, small, right, bigger. And I think they wanted you to draw the picture too. So yeah, you're gonna have to draw the pictures, ladies. Sorry. I want to see your artistic skills. What did public school teach you? 2, 3. Yeah, I went to the Xavier Institute. All right. So negative 4.27. Jeez, way the heck out there. All right, so there's that one. And then positive 2.34. I'm gonna say about there. Okay, so I have to shade from that point to there. I gotta shade it. Looks like it's gonna rain again, ladies, isn't it? Or the sun came out. Did the sun come out? It's gonna rain again. Freaking humid. It's a lot of mold. You know how I can tell there's mold outside? There's mushrooms growing on my yard. They don't taste good, but oh well. Hey. All right. There you go. There's the shading. Holy smoke. It's a hairy snail. Yeah, it's a snail. Look, looks like a snail. Oh, look, the snail. It's a rare species of snail. Okay, so I gotta find that area of all that. Blah. All right, so remember, this is in between. Remember Beyonce song, to the left, to the left. So you're gonna look up the left area of 2.34. And then you look up the left area of negative 4.27. And we're gonna calculate it. We're gonna calculate it. We're gonna have set this calculated. Right, let's do the 2.34. Let's find the left. Calculate it. Calculate it. $99.04. $99.04 is the area of the 2.34. Now I have to put the negative 4.27 here. Left. Oh, look at that. Okay, now, all right, so that one's gonna be tricky. Now this one, if you round it off to 4 places, this one would be 0. So you're gonna have to put this one as 0. I mean, that is just as 0 as you can get. Close to 0, so it's gonna have 4 digits, so that's gonna be 0. 0.0000. Oh, that's why you wanted me to do that one. I get it. I get it. I get it. Get out the way. So it's that. Oh, what the heck happened there? Hold on. I messed up. Oh, what happened? There you go. That minus that is that number. 0.9904. Either or is correct. So there's your 32, madam. 32. Questions? Everybody's all right? You guys are awful quiet. What's up? Okay. Next one you asked me to do was what is up there? 29. 29. I'm running out of paper. Toilet paper. I have paper somewhere. Anyways, all right, 29. By request. 29. We're going backwards. 29. 29 is another between. All right, so this one's going to be probability of negative 2.00 less than z less than positive 2.00. That's interesting. That one looks very interesting. Let's take a look at that one. That's an interesting. You're gonna be shocked to see what the answer to that one is. Well, maybe not shocked. You're gonna be like, wow. Wow. All right, so this is how I wrote it on probability format. It's written in this scheme. Right? That one is an in between. In between. Okay, so again, we're gonna do the Beyonce's to the left. We're gonna look up the left area of positive 2.00, and then we're gonna subtract the area of the left area of negative 2.00. Okay, so let's look them up. 2.00, negative 2.00. $97.73. 97.73. Okay, and then I gotta put the negative left. 0.0228. Much better. I have to put my hydros in my chair. Sorry, ladies. My neck is killing me. Yo no sé por qué. Okay, there you go. 97.73 minus 0.228. I'm going to subtract. $0.9545 or 95.45%. Now, look at the answer that we got. Do you all remember the empirical rule? When we did empirical rule, do you remember the percentages for the empirical rule? There were 3 of them. Let me see if y'all remember. Let's see how your long-term memory is. Do y'all remember the percentages for the empirical rule? There's 3 of them. What were they? You remember them? Oh no, no bueno. No bueno. Ah, you close? Yeah, that okay. Oh, you're so close. Y'all are so close. Now let me see. Enriqueta got one of them right. You get the 99.7. That one's right. The other 2, you yes. Okay, that's the second one. What was the first one? Remember it? It's okay. So yeah, there you go. 68, 95, and 99.7, right? The 68 represented 1 standard deviation from the mean. 95 was 2 standard deviations from the mean, and 3 was the 99.7%, right? Look, this one is 2 standard deviations. Look what the answer was. 95. That's how they got that number, 95. They used this principle to find those 3 percentages. And remember, the normal curve is symmetrical, right? So those are two standard deviations from the mean. That's how they got the 95. Ain't that cool? Things that I could go, All right, what was the other one? 17? 17. Ah, to be 17 again. 17. What was I doing? I just graduated from, I graduated from high school. 17. Yeah, I was a summer baby. So every year the teachers used to tell my mom, you need to hold him back because everyone else is more mature than he is. Wow, that's messed up. You son of a biscuit teacher. How dare you tell me that? I proved them wrong. I proved them wrong. Anyways, yeah. All right, 17. Let's do 17. 17. Let's see. 17 is 17. Less than 1.23. All right, so this one, it tells you too. Probability that z is less than. So I have to write down the symbol for less than. So less than is the one pointing to the left. This is the less than symbol. Less than. Share. There's my less than. There's my less than. So I'm shading to the left. I have to draw the picture. I didn't draw the picture in the other one. Son of a biscuit. Oh man, I forgot to draw the picture of the other. Anyways, you can draw it. Oh. You can wing it too. You don't have to label the entire graph. Just make sure that you plot that number on the right side. So this is negative, so it goes about right here. To the left. There you go. To the left. This one's just to the left. All right. And I'm going to put that into my status. Less is left. Less is less left. Less is left. So that's 5 times. Negative 1.3. All right, left. 1094. 0.1094 or 10.94%. What was that one? 17. Bam! Ooh, their number was off by 1 digit. The book has 1093. Ooh. That's all right. We're good. Swish. Swish. Freaking cold in my room. Moquito. Oh, yeah. Cool beans. There it is. Questions, ladies? Do you have questions? Yeah, the one that's the difficult one is the in between. Just remember, you have to look up the two left areas for the two numbers for the Z's. The other ones are easy. It's less is left, greater than is right. So you have to remember. Right. So what we've done here is you are trying to find the area that's shaded. Right. That number right there is the shading part. Right. That area is provided given that you're given one of these numbers, the Z number. If you know what the Z number is, you can tell by drawing the line the shading of it. Now we're going to go backwards. Let's say that you're given the percentage. How do you go back and get this number? All right. So it's going to go backwards. Oh, I need paper. I need to forget something. I need papel. I need papel. Okay, hold on, ladies. I think I need paper. Okay, I got the paper. Yeah, your tuition's gonna have to go up a little bit. I need more paper. You don't mind, right? Paying an extra 1,000 for tuition. Yeah, you know. Y'all live in the Dominion, right? Y'all live in Helotes, Stone Oak area. Okay, we're gonna go backwards. Now this one's gonna be interesting. So you're gonna be given an area, how to find the Z-score value. Okay, so let me give you all the I guess a rule. You need to draw the picture. Okay. You need to know area of the left side. My brain is thinking too fast today. My medication. Left side. Am I the only one that has neck pains? Are y'all developing neck pains because you're in the Zoom video, doing Zoom all the time? Or am I the only one? I got like, the doctor says that I have a computer neck strain. Am I the only one that's developing that? Ladies don't have that? Pain in the neck.
Go ahead and take the rest of the day off, sir.
I was thinking of just getting a beer later. I was gonna put Vicks or something. Doesn't Vicks make things go away? Just saying.
No, you got to use Windex.
Oh, so when do you use WD-40? What is that used for? They used to sell a little bottle. I don't know. You ask your parents, ask your mom or your grandma. They used to sell a little bottle. It's called Volcanico. It's a little bottle. Looks like syrup. I don't know what it is. But my grandma used to use that for like any ailment that we had. I don't know, it's like motor oil. I don't know what the heck. But that thing worked good. It was mysterious. I don't know what kind of chemicals it had in it. It was called Volcanico. I don't know. Ask them. They're gonna say, oh yeah, I remember that. Yep. It was better than Vicks. It was like 10 times. I bet that would have cured COVID. I never thought about that. I'm gonna have to write that down. Does Volcanico cure COVID? We'll find out. We will test the theory. All right. So here's how you do it. In StatDisk, you know there was another little window that there was another window that appeared. That bottom one is where you're gonna put that number in. Enter in StatDisk, you're going to enter the area. Of course, it's got to be in decimal format. In the second bottom box. Right, I'm gonna let you copy that, and then I'm gonna show you on my notes. Focus. I'll show you. Let me show y'all. So on my note, there it is. It's page 3 of the handout that I gave you all. You're finding the z-score from an area given, right? So I even put it on the notes too. Remember, you should always look up the area of the left of the bell curve. Again, you're going to go to analysis, probability distribution. You go to normal distribution, and then here you're going to put your area in that box right there. Put it on there, and then you hit evaluate, and then what you do is you look at this very top number right there. That number right there is going to be your z-value. And all you ladies have to do is copy it and do not round it ever. And that's it. Done. That's all you have to do. Enter your area in this box, hit evaluate, and then that number right there, that would represent your z-value. Done. We'll have to do something more on 6.2. We're going to use that formula, but right now we're just going to find that number, and that's it. All right, so let me show y'all. I'm going to let you look at that first, and then we'll do a couple of examples. I think there's like 4 of them we have to go through. Because after that, you guys are going to continue doing this stuff. We're going to do that again in 6.2. We're going to do that in 6.4. It's just continuous. So if you're having trouble with it, you'll eventually catch on. It's repetitive. It's a repetitive cycle. You just learn extra things. All right, so we're gonna go to page 240, and I'm gonna show you all how to do, oh, wrong one. We're gonna go back to 240. And now I can show you how to do number 13, 14, 15, 16, 17. We're gonna do all 13, 14, 15, 16. We're gonna do them all so you can see how it works. All right, so on 13, notice in the book, they already drew the picture for you, right? They have the picture for you. So what you have to do first is you need to make sure that the left side is shaded. Okay, it's got to be shaded on the left. If it is shaded from a point to the left, which this one is, you're going to put this number in to stat disk. That's all you have to do. Enter that all 4-digit number, and you're going to put it on the little second box, because this is what we're trying to find. We're trying to find that Z number that it represents. I'm going to draw the picture. I'm going to just draw it because I love to waste ink, and the smell of it is so awesome. Okay. I'm supposed to shade it. I want to say Qingdao, but I can't. Why do I make that sound when I shade? I don't get it. Why I do that for. All right. 08907. All right. So I'm going to put that number in, and I'm going to get the Z number for it. So I'm going to go to my stat disk. I'm going to don't put it on the first one though. Look, even says it here. There are two. Look, on the second one, it says right here, cumulative area from the left, and you put that number 0.8907. Hit evaluate. Presto. There's my answer. My Z number is 1.23026, and you leave it like that. Don't round it. 23026, and you're done. The end. These are very simple. We can do this all day long. Maybe I'll give you like 1,000 of these in the next test. Just saying. That's being too extreme. I'm sorry. Maybe 900. There you go. And there is your answer. There you go. Put in second box in stat disk. Let's do 14. 14. That was the age when my stupid friends ratted on me and told my mom that I was smoking. I was not smoking. Getting emotional. Boy, man, that day was a bad day. And you never tell your mom that didn't hurt. Not good. Bad move, sir. Bad move. I'm almost talking in tongues. Right, let's see. Where is it at? There it is. All right, 14. Notice on 14, again, the graph has already been drawn for you, and the left side is colored in. So all you have to do is enter the that 4-digit number, because it's already been shaded for you already. And the left side is shaded automatically for us. So we just have to enter 0.3050 into stat disk. And that will give me this little Z number that goes right there. That's not equal 0. It's 0 is supposed to be centered in the middle. But we're trying to find the Z number right there. That's what we're trying to find. So we're going to go ahead and go to stat disk. And okay, hold on. I'm having issues with my hold on. Okay, I think I fixed it. I wasn't talking, ma'am. I was projecting my thoughts to you. Did it work? We haven't covered psychic abilities. Okay, we'll have to go over it next time. Okay, so okay, I'm gonna draw my picture. Sorry, I accidentally pulled the sound off my computer and I had to plug it back in. All right, sorry. All right, so here's what I did. I drew the picture. And I'm going, because it's already shaded to the left, so I'm just going to put this number in to stat disk, and I'm going to get the number. And so when I put it in, $30.50, there's my answer. I'm going to write it, and don't forget to include your negative. So my answer for my Z is negative 0.51007. And you type that in, or you write that on your paper, and you're done. The end. That's all you do. Share. Huh? What? What did you say? Victoria, you're making something to eat? Weenies con huevo?
Oh,
no?
sorry.
You're making weenies con huevo?
Oh, what? No. Huh?
Does anyone eat weenies con huevo? Am I the only one? We ran out of bacon and sausage and chorizo. I had to improvise. Yes, we have leftover hot dogs. Might as well make it. Weenies con huevo. There you go. Yeah, improvise, people. Try to improvise. Yeah. So there you go. That's all you do. You just need to make sure. See, notice this one is shaded to the left. It's shaded to the left. So you just automatically enter those two. You automatically enter those numbers in to get that Z number. It is good. I know. We gotta make the little weenies a little burn. Yeah, and then all right. Sorry. I'm getting hungry now. Okay, now that's how you handle the ones that are shaded to the left. Now, notice on 15, it's the shading is a little bit off. Let's check it out. Check it out now. Folks, so brother, right about now. Wait, oh, you guys in the way. Get out of the way. All right, let's look at 15. 15 is a little bit different. That's what the kids used to tell me in school. I was a little bit different from them. All right, so here's the graph. Man, I'm running on the blue pen. Okay, so here's my graph. And notice that the graph, the shading is taking place on the other side, on the right side of it. It's all shaded from a line, but to the right. So, and they label the right side. It's 0.9265, right? So what do we do? What do we do? I don't know. Good luck. I couldn't figure it out. I'm kidding. All right. So what you have to do is you're gonna have to figure out the space right there. We need to know that number because that's the only number that StatDisk will take. It can only take the left numbers. So I know the right side is 0.9265. So to figure out the white area, what I'm going to do is I'm going to subtract this number from 1. Oops, 65. Right, so I'm going to subtract from 1. And so that would give me, I need to subtract, what is it? 1 minus 0.9265, 0.0735. And that's the number that I want to put on my stat disk. This is the right side. I need the left side. So this is the number that you're going to enter to find this number. So let's put it in. And the winner is 0.0735. Oops, there goes my mouse. There it is. Hit evaluate. There it is, right there. Boom! My answer is negative 1.45021. Share. I need to get a picture of share so I can. Every time I say share, I'll show a picture of share. There you go. Boom. There it is. So if the right is given, you get that number subtracted from 1. You will have the left part of the graph, and that's what you need to find that number. You need the left side. The other ones we already had the left side given. This one, the right side was given. So you have to subtract it from 1, and that's the number that you enter into it, the little box. So shall we do 16? I'll let you do it and see if you get it right. All right. Let's see if you all can do number 16. Solas. Con más sola, nunca está sola. What is it at? Come on, come on, come on. Con más sola, nunca está sola. There it is. 16. All right, there it is. 16. Draw the picture. Uh-oh, the right side is shaded. I need the left side. What is the left side equal to, ladies? What is the left side equal to? Freaking birds are making too much noise. Shut up. 0.2061. I need this side. I need the white area. What is the white area? No, I don't mean that in a racist. What is the white side equal to? Uh-oh. What? So figure out what the right side is. Right, so if this is 0.2061, the left side is equal to anyone? It's equal to what? 7939, is that right? 7939. And that's the number that we're going to enter. I need the white side. The white side. Sorry. $79.39. What? Let's see, and to get that guy. Oh, booyah! Very good, ma'am. Excellent. Excellent to the chef. Good move. That is correct. 8200 Very good. Excelente. Excellent. That is correct. Excellent. Good. Very good. Very good. Qué bueno, ganador. All right. I miss Sábado Gigante. That was a show. I thought Price is Right. Oprah, Christina, all embedded in one show. So good show. All right, there you go. That's how it's written. Okay, let's see. We need to do 37 and 39 next. We gotta move quick. Quickly. Okay. Oh no, I dropped the paper. Son of a biscuit. All right. So let's do 37. All right. This time you all have to draw the picture. All right, here, let's do it together. So it says, in exercises 37 through 40, assume that a randomly selected subject is given a bone density test. Bone density test scores are normally distributed with a mean of 0 and a standard deviation of 1. In each case, draw a graph, then find the bone density test score corresponding to the given information. Round results to 2 decimal places. You don't have to do that. Just remember, we're going to just go ahead and just leave it as is. All right, 37. All right, so it says find P99. The 99th percentile. This is the bone density score separating the bottom 99% from the top 1%. Okay, now here it gets a little bit challenging, just a tad. So let me give you some tips when you're drawing. All right, so when you draw your graph, they're going to give you these words: top, bottom, low, high. And you're going to be saying to yourself, well, where do I put the value? Do I put it on the left or the right? If it's bottom or low, it goes on the left side. If it says top or high, it goes on the right. Bottom, low, top, high, you shade, or it's applied on the right side. Bottom, low, left. Okay, that's how it works. Okay, so let's go to our problem and see what those numbers were telling us. All right, so it says this is the bone density score separating the bottom 99 from the top 1. Okay, now 99 is bottom, top is 1. Where do I put the line that divides the 99 and the 1? Does it make sense to put it here and put 99 and 1%? Does that make sense doing it like that? Or would it be better to put it like this? This is 99 and this is 1%. Which one make better sense? That one or the one that I had before? Right? And it has to be this one, right? Because this is 99. And this is 1. Right? It's got to be like that. This is the bottom 99. This is the top 1%. That looks like a mouse. See it? Is it me or does it look like a mouse? You see the ears? Never mind. And the tail, it's a mouse. All right, now that's how we graph it. Now, which number are we going to put in StatDist? Do I put this one or the 99? Which one goes in that second box? This number or that number? So remember the rule. Which one do we put in? That one or that one? That one or that one? That one? Yes, this one. But there's something wrong with it. It's in percentage. I need to write it as a decimal. How do you write 99% as a decimal? .99. So I'm gonna put 0.99 into my stat disk on the second box, and I'm gonna get the z-score for it. Boom! Wait. Boom, boom, boom. Here it is. 2 point. So my z-score is 2.32635. Remember, always enter the area of the left. Always the area to the left. Okay. I think we need to do number 39. What do you think? Let's do 39 together. We'll do it together as a dysfunctional family. I want you to see something cool. Now, you remember a bell shape is it's symmetrical. That means one side is the same as the other side. That's the property of a normal curve. It's symmetrical. All right, we're going to do 39. It says if the bone density scores in the bottom 2% and the top 2% are used as cutoff points for levels that are too low or too high, find the two readings that are the cutoff values. All right, so in this one, you have to draw two pictures. You get one to represent the bottom 2%, and then the other one you're going to draw the top 2%. That doesn't seem right. Okay, anyways. Don't laugh at my pictures, ladies. Golly. And don't be thinking bad things. All right. So one's the top two, and then the other one is sorry, one of them's the bottom 2%. And the other one's the top 2%. All right. Okay. Bottom 2, top 2. Okay, so bottom 2, there it is. There's the bottom 2%. And then here is the top 2%. Okay. And they want you to figure out the Z number that it represents. Okay. All right, so the first one, it's already been labeled. Our left side is labeled. So all I have to do is change 2% to a decimal. How do you change 2% to a decimal? Is it 0.02 or is it 0.2? 2%. Well, 2% is really 0.02. So you divide 2 by 100, right? If you divide 2 by 100, it's always by 100. 0.02. I'm going to enter that number in stat disk. Put that in stat disk. What is it? 0.02. There it is. My answer is negative 2.05375. And so that's the first part. Insure it. There's that number. Okay, now let's see if you can put 2 and 2 together. Okay, remember I told you that the bell-shaped curve is symmetrical. So if this one is negative, what do you think this one's going to be? Any guesses? Any guesses? Take a guess. This is negative. The other one must be, that's correct, positive. Correct. That is correct. It is positive. Ha ha ha. You're like, what? Yeah, it's symmetrical. The distance from 0 to that number is the same distance from 0 to that positive. It's just that it's negative. Now, I can prove it to you. You want me to prove it to you? I will prove it to you. All right. If this is 2%, right, then that means the white area has to be 98, right? Okay, so if it's 98%, I got to change that to a decimal. That's 0.98. Now, if you put 0.98 in stat disk, let's see if we get this number. If I put 0.98, let's see. Let's check it out. If I put 0.98, hakataka, boom. Okay, you get the same answer. Ain't that cool? Ain't that something? Ain't that something? All right, so now that you know that things are symmetrical, right? That's how it works. Questions or concerns? So if the two n numbers are identical percentages, you can go ahead and change the signs. But other than that, you will have to change, you will have to find the left area in order to find that z-score. Wow, it's already 2 o'clock. Can you believe that? I'm kidding, it's not 2 o'clock. It's almost. How long did it take you all to get your that red shelf thing? Remember the book? How long did it take y'all to get? What was it? What did y'all do after all that y'all finally got the book? What did happen? I remember some of y'all didn't get the code. Is that correct? Is that what happened? Y'all didn't get a code or something? What happened? How did y'all get the book after all? Because I'm teaching a an online stat class, and almost everyone is having trouble getting their book, their red book show. What did y'all do after all? Anyone wanna tell me what y'all did? What did y'all do? No one wants to share? Okay. I don't know what they're doing, so well, I don't know. Okay, so let me see what.
I just clicked on my lab and mastering and then it was there.
So you clicked on My Mastering and Lab and it was just there? It just automatically populated?
Yeah, it was I just like clicked through everything and then like put some information in. It was a lot easier than everybody had explained it.
Okay, so you just went to my math lab and just go in there and just register, right?
Yeah.
Okay.
When I registered to get the book, I didn't get it right away. I had to wait like 24 hours and then it was there.
But that day that school started?
Yeah.
Okay, so they had to wait. All right. Excellent. Yeah, this whole thing with the Amazon thing is just a mess. A mess. Oh, yeah. And the students are all mad. They're throwing things at me, calling me names. Toilet paper in my house. Well, that's a good thing because I didn't toilet paper. But yeah. Okay, so we've covered pretty much the basics for probabilities. So let's summarize. All right, let's summarize because you're gonna get confused. So if you are given a probability and you want to find the area, right? Enter the value in the first box in StatDisk. Right. Remember the 3 inequalities. The less than, greater than, and the in between. Okay. If you are given And area, remember, to label the left side of graph and enter that value into the second box. Are you serious? I got the wrong edition. Okay. Good to know, ma'am. Thank you. So, Enriqueta, you still have the wrong edition right now?
Yes, I do, but I don't use it because I was able to like do it on online.
Okay, so all right.
I tried to send it back, and then they started like a claim for it, and they never like got back to me, so I just never sent it back.
Yeah, the
Okay,
same thing happened with me.
Who is that? Desiree? Or who said that?
Me.
Victoria?
Yeah.
Victoria. All right, so, okay, so, and you get them, Victoria, will you look at your email later today? I'm gonna send you something.
Yes. When you like purchase a book, they don't even give you an option to select the 6th edition. They just send you whatever, which is
They send you whatever, right? That's wrong. Okay, okay.
Yeah.
Yeah, I'll, because they sent me something just like recently, like 2 days ago. So I'll send it to y'all. And let me know what y'all think. Okay. Okay. I'm ready to go. So Victoria and Vegeta is not gonna pass this semester. I'm kidding. Okay. Find it. Okay. All right. So there's the summary. Okay. Now, while you guys copy that, I hate to say it, but I'm gonna say it. Word problems. Woo-wee. Don't you guys love word problems? I like them. You guys are awfully quiet. Y'all told me at the very beginning of the semester, sir, I want a whole bunch of freaking word problems, sir. Please just load me up with word problems. You got it. Your wish. The wish is your command. All right. So we don't call them word problems. We call them applications. Okay. So, on the word problems, it's gonna be kind of like well, it's okay. So in the medical field, you can't measure heights, weights, like pounds or feet. You have to measure them in metrics. So you have to do some sort of conversion from feet to centimeters, or from pounds to grams. Right? That's how the process is going to work for these applications. You're going to have to convert. So you're gonna be converting from real life into the normal distribution. Okay, so in real life, we're going to write probabilities as probability of X, blah, and then we'll have inequality, less than, greater than. And so you're going to convert it into a normal. And the normal converts from X, it's going to convert to a Z. And you're going to keep whatever they use in the real life, whatever symbol, we're going to use the same symbol. We're only changing the variables. X is real life, normal is Z. Okay. And when we do real life, okay, our bell shape is going to be a little bit off with the scale on the bottom. This scale is going to represent X, right? So, like, let's say you took body temperatures of individuals, right? So, typically, the mean body temperature is 97.6 or 98.6. What is it? 98.6, 98.7. I think that's the mean body temperature of a human body. 98 point something like that. I don't know. So you're gonna have it's gonna have its own mean and its own standard deviation. When you convert, we have to convert. That's what we're gonna do. We're gonna be converting. We're gonna convert. This is gonna change to mean is 0. Standard deviation is 1. This is our Z scale. Remember our Z? We were just doing that right now. So we're going to be converting. So the conversion formula, I'm going to give it to you. Conversion formula. Convert. I don't know how to spell conversion. Conversion formula is going to be Z equals, in parentheses, X minus mu over sigma. That's going to be the conversion. We're going to convert from real life to normal, and this is going to be the formula we're going to use. So once you calculate this formula, okay, you're going to round answer to 2 places behind the decimal. It's going to get a little bit complicated because there's going to be some rounding rules that we're going to have to follow. So once you convert, once you go from there, you're going to use that formula and you put it there. Then you can use stat disk and find whatever the probability is for that particular thing. So we're gonna run some examples so you can get the feel for it. Okay, it's very simple. You're gonna continue. It's kind of like algebra. Once I show you how to do like solve a linear equation, the other ones are gonna be the same. You're gonna do the same steps over and over and over. We're gonna do that for this section, and we're gonna do this for section 7.4 with a little modification. But it's gonna be a repetitive cycle, not cycle, but cycle. Big difference between cycle and cycle. Yeah, cycle. It's a cycle, not cycle. Well, you could go cycle if you do a whole bunch of these, but yeah, not cycle. Cycle. It's a cycle. All right. So they're gonna give you the mean and standard right off the bat. All right, so let's suppose we're gonna change your neighbor, people. I mean, we're gonna change your major. Yeah, we're gonna change your major. We're not gonna be nurses or cybersecurity. We're going to change your major to a psychiatrist. All right, so you work for a doctor psychiatrist. Psych. Did I spell it right? Psychiatrist. Psychiatrist. Dealing with young adults and are tested for IQ. Okay. And the mean is 100. And the standard deviation is 15. Right. That's what they give you. Testing IQ. Right. So the first question says, find probability that the IQ scores of this group have IQs less than 100. Okay, less than 100. All right, so right off the bat, they're giving you the X. So this is real. This is the real life. This is real life. All right, so you're gonna write down your probability. You're gonna put P X less than 100. Okay, and you're going to convert. I'm gonna put a little arrow. I'm gonna put on top of there. I'm gonna put convert, and I'm going to use my formula for my conversion. So my conversion formula was Z equals X minus mu over sigma. I'm gonna draw it as a box, so that way I won't go outside of it. And you're gonna go ahead and enter the numbers. All right, so this X value is gonna be this 100. All right, that's what this X is. X is gonna be the reading that you're going to be testing. This is 100. So 100, I should underline it. 100, which is what you're gonna make in your next test, right? 100 minus, okay. Well, there's my mean. My mean is 100. And then I'm gonna divide it by 15. Okay, and then you're gonna calculate it in your calculator. So 100 minus 100, that is 0. Divided by 15, you get 0. Well, you can round it off to 2 places behind the decimal, so we're gonna leave that as 0. Okay. So once you convert, you're gonna write your probability. It's no longer gonna be X. Now we're dealing with the normal. So you put a Z. You're gonna keep this symbol, and then you're gonna put the number that you got from your answer, and you're gonna put it right there, like that. Well, right there. There's your 0. Normal distribution. Right. And then you're gonna go to stat disk, all right? Because this is less. Less means left area, right? correct? Not that area, right? Left area. Area. Okay, so you're gonna go to stat disk. You're gonna put 0 in stat disk. We're gonna put it in the first window. You put in the first window to find it. Okay, move you all the way. Get. Erase that. We don't need that. We're gonna put 0, right? And we said that it was left area because it's pointing to the left. It's less. And so there's my answer. It is going to be 0.5 thousand. And then the answer we get, you have to round that one to 4 places. So I got 0.5 thousand or 50.0%. I get y'all away. Switch. I went too fast. Okay, we're gonna do a whole bunch of these so you can get the feel for it. It's 12 o'clock. Can you believe it's 12 o'clock? Okay, so that's how the process is going to work. You're going to write down your probability. You're going to do your conversion, right? Remember, this is your x, and then you're going to enter these two numbers. This is your mu and your sigma. You plug it in, compute, divide, whatever this answer is, round it 2 places behind if possible. This one was 0. You write your probability statement again, but instead of writing the x, you're going to put a z, keep the symbol, and you're going to put the answer that you got from the box. You're going to put it right next to that symbol, and then you look it up in stat disk and recall what the inequality symbol meant. If it's less, it's left area. If it's greater than, it's right. If it's in between, then we have to find the left areas of both numbers. So that's how it works. Okay, so I'm going to do one of each. So I did a less than. Okay, so the probability that these patients have IQs less than 100, that's 50%. Wow, 50% of the patients have IQ scores less than 100. That's what it's saying. 50% of the patients have IQ scores less than 100. They were probably studying to be politicians, just saying. Right, so there's a less than. All right, so let's do another one. Let's do the let's find the probability. We're going to use the same criteria, all right? So you're still working with the psychiatrist, you're dealing with IQs. And this time, you want to find the probability that they have an IQ scores greater than 130. Right? Whoa, 130, my word. All right, so what do we know about these students? These students are going to be super bright. There is a club for people with high IQs. Does anyone know the name of the club that they would qualify to be in if they're super smart? Take a guess what it is. What's the name of the club? The name does just not match with the type of people that are in that group. Does anyone know what it's called for smart people? Okay, it doesn't make sense, but hey, this is what it's called. It's called Mensa. Yeah, that's what it's called. In Spanish, it's totally the opposite. Totally the opposite. Totally the opposite. I remember my grandma telling my sister, "Ay, que mensa." Oh, that must mean she's super smart. Apparently not. Apparently not. Yeah, they're making one for guys. It's called Menso, but so it's so stupid, man. Why do they call it Mensa? I don't get it. It just doesn't make sense. Wow. And look it up. You have to look it up tonight. You're gonna laugh. You're gonna, what the heck? It is true. It's called Mensa. Well, freaking people didn't think before they made the name. Let's call this Mensa. All right, anyways. All right, here we go. So here I'm going to write down the probability again. We're going to convert. Right? I'm still using the fact that my mean is 100 and my standard deviation 15. All right, so I'm going to do my conversion. Here's my box. Conversion box. Z equals x minus mu over sigma. And we plug them in. So there's my x. This is 130 minus my mu. My mu is 100. I gotta put it in the color. Hold on. 130. Yep. Red and blue make red and blue. Divided by 15. All right, I'm gonna put that in my calculator. And let's see, do I need to round? Let me see. What is 130 minus 100 divided by 15? Ooh, look at that. I get 2 or 2.0. So now I write my probability. I'm going to change that x to a z. I'm gonna keep the symbol. And I'm going to put my 2 here. So this is greater than, which means greater than means I'm going to shade to the right area, right? This is the right area. I'm going to put that in my stat disk and I'm going to look up the right area. 0.20. 2.00, sorry, 2.00. And I'm going to get the right area. And my answer ends up being 0. I gotta round it to 4 places. 0.228. Or what is that? 2.28%. So 2.28% of the patients have IQs that are above greater than 130. That's a very small pool there. Very small pool. Not a lot of Mensas in that group. Not a lot of Mensas. These people should have taken Spanish before they made that name, Mensa. Nemo. Okay, so we did a less than. There's a greater than. We need to do one more. We need to do one that has an in between. Let me see if I can fit it. I hope I can fit it. Okay, so let's do one that has an in between. So you'll have probability of, let me think, IQ scores. Let me think. 105 less than X less than 122. Right. So there's an example of the in between. Okay, so I'm gonna write down my probability. I hope I have enough space. We will see. And we're going to convert. Now, when we convert, we got to do two of them. We got to do one for the 105 and we got to do one for the 122. So I'm gonna have to write my formula twice. I'm gonna do Z equals X minus mu over sigma. So I'm gonna do it for the 105, but then I also have to do it for the 122. And let's plug it in. So I'm gonna put 105. Here's my 105. 105 minus 100, because that was my mean, right? That was my initial mean. My initial mean was 100, and my standard deviation was 15, right? Divided by 15. And then this one I'm going to do 122. Minus 100. And I have to calculate each one. I'm going to get two answers. Well, two answers because we have two numbers. And we plug it in. Here we go. I'll do the first one. 105 minus 105 minus 100 divided by 15. Oh, look at that. Look what it gave me. It gave me 0.333. We'll fix it. I need two places behind the decimal. .33. I have to have two behind the decimal. My Z's have to have two. All right, let me calculate this one. .4666666666. That's evil. I need two numbers behind the decimal, so I'm going to put 1.47. 1.47. That's going to round to 1.47. Remember, these numbers that are in the formulas, they have to round to 2. You have to have 2 digits behind the decimal. Always 2. Okay. Once you have those two numbers, you're going to rewrite this probability, but instead of these numbers, I'm going to replace them with these. 0.33 less than Z, because it changed to Z, and then 1.47. It's exactly how we're doing conversions. We're like changing it from feet to centimeters. That's what's happening. Okay. And so here's your converted from real life to Z. And now you guys remember what to do next when you have a in between. You don't have to draw the picture, but this is the Beyonce one, right? To the left, to the left. We're gonna look up the area, left area of 0.33 minus the left area. Oh, wrong one. That should have been 1.47 first. And then this one should have been 0.32. Remember, the bigger number goes first, right? Not that it mattered. But yeah. So we're going to look it up. We're going to get those two areas and we're going to subtract them. All right, let's look up the 1.47 first. To the left, to the left. 9292. 0.9292. Minus. Now I gotta put the other one. 0.33. 6293. 6293. I got my two areas. And now I have to subtract. Subtract. Yeah? Yeah. Lettuce, tomato. Lettuce, tomato. Let us subtract. Oh. 0.29. Wow, interesting. 999. Huh. So 29.99%. Wow, that's weird. I didn't think that was gonna happen. So 29.99% of the patients have IQs between 105 and 122. So you can use this like when you guys go back to school. I don't know if y'all are gonna go back to campus, right? Y'all, how many of y'all are going back to campus? Y'all going back to campus in the spring? I mean the fall? Right? You can calculate how many. You can't ask this question, but I mean I guess you could, but the instructors, we cannot ask students if they got vaccinated or not. Can you believe that? I would be curious, but I mean, you can't ask that. That's kind of. But anyways, in Texas, you can. But you can figure out, hey, how many? All right, so I'm gonna go back to class. So within my class, how many have not gotten vaccinated? Right. So maybe you haven't gotten vaccinated. We can figure out the probability of, and if they do Where'd y'all go?
You
I
said class
lost
was
y'all.
over.
No, I was still talking. I was still going. I was already in chapter 8. Oh my gosh. Did y'all go eat lunch or something? With the frog? Oh, someone left? Wow. That's messed up. Oh, who left? I'm gonna have to drop them. I'm kidding. Oh no, not again. Oh, I got scared. What happened? I didn't leave. Y'all left. I did not leave, Natalie. You left. Yeah, I don't know what's going on. Is there a storm coming or what? Oh no, the Sahara Desert dust is coming. That's what it is. That's what it is. The heck is going on with my computer today? Son of a bitch. Well, anyways, going back to our problem. I was rudely interrupted. I lost everything. Had everything all set up and everything. Dang it. Son of a bitch. Anyways, so you can use this to figure out like what's gonna happen when you all go back to school. And because I can't ask the students about if they got vaccinated or not, because I'll get in trouble now. Isn't that dumb? Anyways, you figure out what the probability that you can catch COVID, in a class that you don't even know who's got it or not. I don't know. So that'll be a problem. We'll find out. Bueno, muchachos, I think we're gonna have to stop here because I don't know what's going on with my computer. And then plus you all wanted to go eat weenies and egg, right? I don't necessarily want it weenies and egg. Anyways, all right. So we shall stop here and we'll continue on Wednesday. I think we'll finish on Wednesday 6-2 and 6-4. Bueno. Preguntas? Boy, you really want to go, don't you? All right, ladies, you all have a great day. Don't talk to strangers, Victoria.
Dang it, so close.
I know, you tried.
Goodbye.
Bye. You too, bye, Enriqueta.